When I was an undergrad, my junior year, I was a math major, right? And I took some classes just because I thought they looked interesting. I took this astronomy class called kinematic astronomy. It's studying the motion of planets and objects in space. And I mean, I was a math major. I'd taken trigonometry. I thought I kind of knew my stuff. Let me tell you, that professor, Heinrich Eichhorn, still remember the man's name, he had forgotten more trig formulas than I ever knew. All right, from such simple beginnings, the ratio of the sides of a triangle, the relationships between these trig functions are practically unlimited. What we're going to do in this lecture, we're going to look at a process called verifying identities. So I'm going to give you this formula, right? If the secant times the cotangent is the cosecant. And the goal here is to prove that this is true. And the way we do that, and it's a little bit rigid the way we do this, you need to work on one side of the equation and only one side. Usually that's going to be the busier of the two. So I'm going to start by manipulating the left side until I have made it equal to the right side. Okay? It's really important that you do it this way. You could theoretically get away with manipulating both sides, but there are all sorts of pitfalls that you can fall into. All sorts of things you can do that maybe look okay and really aren't. So unless you're super familiar, super squared away with the properties of trig functions and so on, stick to working on one side. Right? And another quick point, to do these, you really need to be squared away on all the formulas we've been talking about, because those are the things that we're going to use to do our manipulations. So one technique that's common when we're answering this kind of question is to take everything on the side that we're working on and rewrite it in terms of sines and cosines and see if that doesn't simplify things. All right, so I'm going to start with secant times cotangent. You notice I don't think I've really done this before. I'm not writing the theta. We know it's theta, right? And because we kind of know what the variable is, in the interest of minimizing clutter, I'm not going to write it over and over again. Right? The only time we really need to be particular is maybe we're doing something with two variables, which doesn't happen real often yet. Okay? So this is going to make our life a little easier. So now I'm going to use my definitions. The secant is 1 over the cosine, and the cotangent is the cosine divided by the sine. Well, look, now I can get some cancellation. The cosines cancel, and this is just 1 over the sine. But wait, 1 over the sine, that's the cosecant, and that's what I wanted to show. Right? That's how this process works. I took one side, I used my definitions, my formulas, my identities that I already knew, and used them to manipulate it until I got the result that I was looking for. All right, so let's try another one. As a matter of fact, I'm going to pause this one. Right? Let you take a look at this. See, I know it's a little early on, but see if you can't work this one out. I'm thinking it's the right side that we're going to want to work on here. All right, so let's start with the right side. Sine times secant plus cosecant. Right, I'm going to do what we did before. I'm going to rewrite everything in terms of sine and cosine. So that sine out front is going to stay the same. Secant is 1 over the cosine. Cosecant is 1 over the sine. And now let's distribute. Right, shoot that sine into the parentheses. The first term becomes sine over cosine, and the second term is sine over sine. Well, sine over cosine, that's tangent, and sine divided by sine, that's 1, and that's what I was aiming for. That's the other side of the equation. Okay, why don't you try this one as well? See what you can make of this one. Obviously, it's pretty clear we're probably going to want to work on that left-hand side. Okay, so the first thing I'm going to do, this is another kind of common technique we use with these things. Use the negative angle identities to clean these things up. All right, first, and I'm going to rewrite these just a little bit so you really see what's going on with the exponents. this is cosine negative theta squared plus sine of negative theta squared equals 1. Well, the cosine of negative theta is just the cosine of theta. Still squared. Plus, the sine of negative theta is negative sine theta squared equals 1. Okay, so this first part, that's just cosine squared theta. Plus, look at what happens here. Minus sine theta squared. A negative number squared, it's a positive number. So this is just sine squared theta. And yeah, that equals 1. Right? That's what I was trying to show. Okay, how about this thing? Well, I'm going to let you have a go with this one as well. All right, take a look at this one, see what you can come up with. Okay, really, you could kind of come at this one two different ways. You might even be able to do this working on the smaller, on the sine squared side. So let me do both. Right? Let me start by working on the left side. 1 minus cosine times 1 plus cosine. Well, again, you kind of let the equation itself be your guide. The natural thing to do here is to multiply this out. Right? This is 1 minus cosine squared. All right. And here, this is where it's going to get a little creative. All right. 1, I'm going to go to the Pythagorean identity. 1 is cosine squared plus sine squared. Still minus cosine squared. And that gives me what I wanted. The cosine squareds cancel. And all that's left is sine squared. Right, now let's try this the other way. Let's try looking at that sine squared theta. Well, sine squared theta, that's 1 minus cosine squared theta, right? That's the Pythagorean identity. The Pythagorean identity is cosine squared plus sine squared equals 1, but if you subtract cosine squared from both sides, you get sine squared equals 1 minus cosine squared, which is what I did right here. But now look, that right-hand side, it factors. Think about how 1 minus x squared factors. That's 1 minus x times 1 plus x. Well, this is going to be 1 minus cosine theta times 1 plus cosine theta. And hey, look, that's the other side. Right, so this time, I don't know which one was easier. It kind of depends on which one you see first. Right? But it worked out the same either way. Okay. How about this one? This one, so it's a little messier, but look. So let's do what I said to do before. I'm gonna work on the left-hand side. Tangent plus 1 over cotangent plus 1. Tangent is sine over cosine plus 1. Cotangent is cosine over sine plus 1. All right, so let's add these together now. Look, I'm gonna turn this 1 into cosine over cosine. So now I've got a common denominator there, right? I'm going to do the same thing on the bottom. I'm going to make this sine over sine. And now I can add those together. The numerator is sine plus cosine over sine. And the denominator is cosine plus sine over, the numerator up here. The numerator is sine plus cosine over cosine. The denominator is cosine plus sine over sine. Now, how do we divide fractions? The first one stays the same. Sine plus cosine over cosine. Change the division to multiplication and flip the second one over. Sine over, look, I'm going to rearrange the order there, right? I'm going to make this sine plus cosine, because now you can see what cancels. So this is sine over cosine, which is tangent. right? And that's where I wanted to end up, right? That does equal the tangent of theta. All right, let's you try this one out, right? Try this, see what you can come up with. Okay, I'm going to work that left-hand side. 1 minus cosine squared over 1 plus cosine. And I'm thinking, let's try some factoring. I'm going to make this 1 plus cosine times 1 minus cosine over 1 plus cosine. And now look, stuff cancels. Right, those go away. And look at that, that was quick. All that's left is 1 minus cosine. That's what I was trying to show. All right, another way, I could have worked on the left-hand side, right? I could have started with 1 minus cosine x and then done this, right? Make that over 1. Multiply this by 1 plus cosine over 1 plus cosine. That's fair, right? Let's multiply the top and bottom by the same thing. The numerator here, if you multiply that out, is 1 minus cosine squared. And the denominator is 1 plus cosine. So it works either way. Right? Again, I saw the left-hand side first. Right? I saw that 1 plus cosine on the bottom and said, yeah, I bet that's going to be a factor, and it'll cancel out. But, if you see the other side, that's fine too. Right? Works either way. So this one is a little bigger. Right? It's a little more complicated. I'm thinking I'm going to work on that left-hand side. So let's say 1 over 1 plus cosine plus 1 over 1 minus cosine. And again, I'm kind of let the equation itself guide me in what to do. If I see two fractions like this, my first thought is, well, let's combine them together. And to do that, they need a common denominator. So I'm going to multiply this first one by 1 plus cosine over 1 plus cosine. I'll multiply the second one by 1 minus cosine over 1 minus cosine. And what does this turn into? I get 1 minus cosine over, and if I multiply these out, this becomes 1 minus cosine squared plus, the second fraction is 1 plus cosine over 1 minus cosine squared. And now I can put them together. 1 minus cosine plus 1 plus cosine over 1 minus cosine squared. And the numerator is going to clean up. The cosines cancel. 1 plus 1 is 2. And look, 1 minus cosine squared, we saw this in a previous slide, right? That is sine squared. But what's 1 over sine squared? 1 over sine squared is cosecant squared. So this is 2 cosecant squared, and that's what I needed it to be, right? That's the right-hand side of the original equation.